We just got an enormous package here from our friend Frank Perez, so you know it's going to be interesting. Let's open this up and see what we got. Bubble wrap, my favorite. Frank, you're killing me. I guess somebody left the tubes in. Sent me luggage? Okay, so it took me a second to figure out what's going on here. This is a portable AM radio, right? And we can see the broadcast band radio here. It may actually be FM or shortwave too. I'd have to take a closer look at it. We're just going to say it's radio for now. But it's also phonograph in the back, right? So the phonograph comes up, and it's 78s, as it would appear to be 78 RPM shellac discs, right? And obviously some sort of amplifier, and it switches from here to here. There's also a magic eye tube in the top right corner of this device. And this would appear to be made by the Port-o-matic company. I've never heard of them before. So this is nuts. Here's the arm and stylus right here. And it almost looks like, or I imagine it is like, you put the record on and then close the lid to play it? That's ridiculous. Does anybody see that? This just kind of drops down on the record and just plays with the lid closed. Right, and it has, you know, removable, almost like what you call single-use needles, right? And it would just be stored in here, the old style, like I have for the Victrola, right? It has also, you know, the standard speed adjustment down here. Platters on an electric motor. Very interesting. Switches AC 110 volts or DC 110 volts. I mean, I get the DC. There's probably no transformer in here. I'm betting that there's no transformer in here. I guess we'll find out, right? But that's my guess, having not opened it. This is gonna be like a transformerless 5-tube setup in here with some sort of input for phono. But we're gonna have to crack it. I want to figure out how to open this thing. I'm going to guess that everything starts here with these 4 flathead screws that sit around the perimeter of the turntable. So I'm going to take those out, and that's probably going to lead me towards the speaker, which is just behind my hand, and this is where the radio is. So we've got an old Flyer electric motor right here, 115 volt AC or DC, 78 RPM, and take a look here. It's got an old centrifugal style governor that you would find on motors of this era. This is outrageous. Look at that. Very nice indeed. It's like looks like like wrought iron or something. Fabric covered wire, right? For the time, seems about right. And that leads up to the switch right there. And some more cables down here. Everything terminates here on this bus board below, makes its way into the other side. I notice right off the bat that there is a wire that is found here to be hanging and goes nowhere. So I'm looking in the back of the radio. I see this cover here and some damage here. A little bit of damage everywhere, but I'm going to remove this cover. It seems that there has been work in back of here. I could see the tubes are missing from sockets just looking in here, so we'll see what's what. So I'm going to remove this now. We can see the tubes have indeed come out of the sockets here. And this piece is cracked on both ends. 25L6. Z6. Looks like there's probably a third in here hiding somewhere. I'm gonna have to fish it out. I found the third tube was hanging stuck up here. pulled off the knobs in the front. They're actually made of wood. They have this little retainer in there in preparation to remove the radio. It looks like there are two set screws here, one over here and one over here, and then this wooden block on both sides comes out, and that allows the entire unit to slide back. I believe that's how the radio is going to come out of here. I think the best thing to do is to cut these connections in a way that I know how to reconnect them. They're a little worse for wear anyway. I'm going to do that now. Getting that out of there made things so much easier. Also, to remove the radio phono switch from the front, unscrew it. With that, it finally broke loose. I'm able to pull this back, see what we got here, and it looks like the magic eye tube is socketed. And just disconnect that socket here. And it is removed from the unit. We'll get this out of the chassis now. Thank God. This chassis is just a nightmare to work with. One last thing, I pulled the magic eye tube from the chassis as well. This would be part of the troubleshooting. So in the meantime, I put the platter back in so nothing gets damaged. Close this back up and get this monstrosity the hell out of here. The underside is covered by a piece of wood with 3 flathead screws that I'll have to remove to gain access to the bottom. And finally removed. Oh dear. Yeah, it's all wax caps. Oh geez, how old is this thing? Some old school components in here. We got some dominoes, wax caps. Try and pull a date off of this thing, but look at this. Thing has seen better days. I can almost guarantee that every capacitor in here is garbage, especially when you consider that the line voltage for today is so much higher than it was back then. Some of these look like they're barely above the operating voltage then for the maximum amount of voltage DC. So yeah, I would be amazed. Let's just make sure this thing works mechanically and that the transformers work and everything like that, if it's worth saving. Also, I'm going to point out, it looks like a filter cap here. Look at the size of this thing. It's 32 microfarad. That's enormous for a 32 microfarad cap. Like, wow. I'm just saying, you know. All that for, is that a single? I'm gonna have to look under. It looks like just a single capacitor. That's, Jesus Christ. I feel like a little tiny 32 microfarad under there to replace it. I'm gonna go and pull a schematic at this point. All I know is it's a Port-o-matic. I haven't been able to pull a model number off of this chassis. I was hoping I would. As I suspect, it is an AC/DC death trap. Just looking at the tubes tells you that if you add up the voltage of the filaments. It was not easy to pull up a schematic for this device, figuring out even what it was. Turns out that this is a Port-o-matic. The circuitry in here is a model P8 from 1938, and I'm going to tell you how I figured it out. The red herring is right here in this section called BK23B, and this is what messed me up. If you look at these tubes here, the heaters, 1, 2, 3, 4, 5, 6, 7. There are 8 tube sockets. I was looking at the 8 tube sets because there are, in fact, 8 sockets, right? What I come to find is that one of them is not a tube, and it wasn't until I started taking them out, because I knew if I took them out and I didn't remember where they were, I was going to have to identify them under the board, right? So I started doing identification, except for the 2 that were removed where I didn't originally know exactly where they were. And I came across this thing right here. And it was funny because it didn't have any designator on it. Just had this BK23 Bravo. So I wrote it down, right, and its location, so I wouldn't lose it, and went into the socket right here, right? And I said, wow, this is kind of, feels a little cheap for a tube, right? And as it turns out, it is not. It is just a couple of resistors that are used to drop the voltage in certain locations here right off of the line before it goes to the heaters, and before it goes to the rectifier, or basically the rectifiers are being powered by the voltage drop off of the 10 ohm resistor, and then the rest of the filaments are being heated by the resulting voltage after the 60 ohm resistor. So it looks like a vacuum tube. It's just a couple of resistors. That's pretty funky, right? So that's what that is. And that just goes right over here. So because it is the only radio that contains this style resistors in it, yeah, that led me to this. And then I was able, after that, to verify all of the other tubes are contained in this and their locations, and then trace back other components, and finally determine that this is the exact set. So now I have a schematic for this unit. I'm going to say that the first order of business is probably going to be to test out these tubes and read the resistance off of this resistor, strange as it may seem. The first tube I was trying to test, the 6E5, does not have a listing in my chart for this tube tester, but I guess that's okay because I can just check the performance of this running in the radio to see if it's bright on the display. So we're just gonna have to skip this one. So this is the 25Z6, the first one. Watch the voltage drop on the meter by the line adjust when I plug this thing in. Look how much current is drawn, how much voltage as it heats up, and you'll see that it comes back up to a degree, you know, as the tube heats up. But wow, that's something. That's 25 volt heater right there. So I'm gonna wait for a little bit for that tube to come to temperature before I readjust the line. I see that the no gas, no short, and I'll hit the quality button, and we can see that this tube is good. So I'll mark that as good, and I'll do the next one. And here's the next 25Z6. I haven't even adjusted the line adjust yet because I know it's going to drop. And we'll see if it comes back up to the middle once it heats up. And I figured it would. So we'll let that come to temperature, and then I'll run my check. I see no gas, no short. The quality test shows this one to be good as well. So that one is just fine. I'll pull this one out. We'll move on to the next tube. Next is a 25L6. Again, all of them put significant load on the unit. I have this set up, taking a look. There's no indication on the lights that there's an issue. It's still climbing. I'm going to give it just a little bit longer. But I can see it's climbing slightly. This tube is acceptable, so I'm going to move on. This is a 6A8. I'm going to try this one now. This one also has no special instructions. We'll see what's going on here. This one tests good. Here's a later reading I'm doing of the 6K7, a reevaluation. 1450 shows 1500. This tube is good. A reevaluation of the 6Q7 is supposed to be 800. It's showing about 890, so that's just fine, absolutely perfect. We'll move over to the next sections of this. Following two tests will be pass-fail. And we can see that that is good. We'll move to the next one. Here's the other diode. And that one is good as well. This tube is good. I'll point out that my meter adds 3 ohms, so keeping that in mind, we could see 76 is actually 73 ohms, right? It should be 70, so that's pretty good. If I look here, I see 63 ohms, should be 60, right? So 7 and 8, this should be the 10 ohm resistor. And it's actually 12 ohms. So yeah, so this module works just fine. Parts have arrived for this unit, and my first order of business is going to be replacing the electrolytic capacitors. This is going to provide me a lot more room in the chassis to work. They're the bulkiest of all of the items. That includes these right here, the one on the other side that can't be seen right now with the large can, which I'm going to leave the can and cut off and replace with one on the bottom. This 25 here and the 12 right here. We could see a substantial size difference between the old capacitor and the new one. This is a substantial increase in space available. Also, I bring the positive side as close as possible to the tube socket I don't have to put any heat shrink on it, as well as it doesn't expose any extra possible interference. Here's our next example. Now I've got the second one in. For the next two, I'm going to use the tie-off, the original tie-off that's sort of welded to the chassis, and I'm going to put some heat shrink over it, make a nice connection, and do these one at a time. Those two caps are now replaced. A lot more room to work down here for the final electrolytic capacitor. And that cap way back there used these red and black cables protruding from it. We're going to leave the cap in, but we're not going to use it anymore. The black cable is benign because it's simply going to ground. I'm going to leave it alone. That red cable makes its way all the way back and comes here to this first rectifier down on the bottom. So what I'm going to do is I'm going to remove that cable from the rectifier. We're going to attach the positive of our new capacitor in, and we're going to tie off the negative of that capacitor to the common ground, and that's going to be the solution. There we go. The installation of the final electrolytic capacitor is complete. Before I did any further work, I wanted to grab one of these other wax caps at random, but one that I wouldn't have to cut out a circuit in order to do this test. And I found this one right here. This is a 0.01 at 400. What I wanted to see is if there was any excessive leakage on these. And I know there is, but this is my only opportunity to do this without skewing the results. I apply heat to them. I may destroy them anyway upon removal. I could clip them out and test them, but then it's purpose defeating, right? So this one I found, this one is an open in circuit, and I'm going to hook it up to the IT11. We're going to take a look at this. Now these are supposed to be lightning fast paper mica, right? So there's 3, 6, 10, 15. This bad boy's slowing down. You see that? 100. Oh, that's terrible. Look at, yeah, garbage. 200. 200. These things should be lightning quick. It already crapped out at 200. That was unexpected. 250. 3, yeah. So that one's bad. Let me get a sample of another one. Okay, found another one, 0.05 at 400. And here's 3, 6, 10, 15. And that is 25. It's already excessive leakage. And this should be good to 400. So yeah, they're all garbage. Every single one of them is garbage. I clipped this one out as to not damage it. I wanted to see what the reading was. It was previously untestable in circuit. This is good to 200. It's already slow. Garbage. Garbage at 50. Next one, good to 200, is garbage at 100. The next one, good to 200, is garbage at 25. And here are the new caps in place. This particular one, I tied off the existing wire. I did not want to risk damaging the coil, so that's how I did that. I got a nice union in there, and then I added a piece of shrink wrap to insulate that. Also, I haven't soldered these ends yet to the star ground. I'm waiting until I get this third one in, so I do the soldering all at once. This one will be interesting because I have to remove this and put this component on the new capacitor as I do this job, so. And this one read garbage at 25 of 200. This one rated to 400, made it all the way to 200. This one rated at 200, quit at 100. Now, exactly halfway through the chassis with everything, things are looking real nice and lots of room to work. We can see the bottom half, electrolytics are done, but the other capacitors are still in there. We'll be removing those shortly. This one's rated to 400, fails at 25. 200 fails at 50. This one's rated at 400, good to 25. This one actually had the wax pour out the side. And it was rated to 400 and it died at 100. This one rated to 400, died at 25. Last one is supposed to be good to 4, died at 150. I have completely recapped this entire unit. The recap job is now finished. So this is what we're going to do, and I apologize, I don't have the gimbal today, it is charging. We're going to shake out any of the lead and whatnot that's fallen on the bottom. We're going to lay this back down, and we're going to start populating this with tubes. I made sure I put the wooden knobs back on, not in any particular order, as long as the knobs are on there. When you deal with these AC/DC radios, there's a better than even chance that you have a hot chassis. You could go and touch one of these knobs and knock yourself across the room. So we're going to be checking that, but still, this is always good practice. I've also got the radio phono switch set to radio to ensure that there's no power that would be sent out to the motor. We'll do an overhead shot here. This is what it looks like with all the tubes repopulated in the chassis. Power is turned on the unit and the volume is up at 50%. We're going to be applying power from the variac naturally, not from the unit. Variac power is on. I'm slowly going to bring up voltage. I get it to about 40 just so the meter kicks on. I can see it lighting up there. It tells me the pilot is working. Right, we're getting voltage. I'm going to just turn it up to half voltage right now, and that's 60. And with that, I'm going to take a look and see if we have any glow. We're at about 80 volts now, and I can just start to hear just a little bit of crackle coming out of here. Everything seems good, current seems good, so I'm going to kick it up a bit more.
Grocery stores, banks, medical
so apparently there's a light here that switches between shortwave and broadcast. See, that turns on shortwave, and then it's supposed to be a light for broadcast, which apparently I'm just going to have to go and replace that bulb. But for now, I got something coming out of here. So I put a new bulb in up top. So this is AM, and there's shortwave. That's pretty cool. I shut off the backlight here to show that the Magic Eye is working, but it's extremely dim. Here's the thing, when I tested this on the tube tester, it shows that the Magic Eye is actually working fine. So there's a good chance that one of the resistors that drops down the plate voltage probably went a bit high and the voltage is too low. So we'll take a look at that later. I had to wait till the evening to find out that even the shortwave side is functioning. Heard something there. This tells me it's at least working.